Hi, my name's Amy. I'm going to give you a very quick lesson in the periodic table of the elements. First, go find yourself a periodic table of the elements. Pretty easy to find on the internet, print it out, or it's in most science books from elementary through college, depending on the subject. I have one here. I'm going to just talk to you very quickly about how to read this. First of all, every element has a number that's either right above it or right below it, depending on whoever drew the table. And it starts with 1, goes over to 2, way up here, 3, 4, 5, 6, 7, etc. You're going to see that every number is on a different element because that number is called the atomic number. That means the number of protons in every atom of the element. And that actually is the identity number of the element. So, say for example, lithium has 3. Every lithium, ever, whether it's in a rock or any other form, will have 3 protons. And the only things with 3 protons have to be lithium. As soon as an atom has 3 protons, it's automatically lithium. That's it. It's its identity. This first group, by the way, they're organized in groups, so every element and the ones above and below it have similar properties. This first group is called the alkali metals. It includes hydrogen, despite the fact that hydrogen is a gas, because what they have in common is that they all have 1 electron that they're kind of looking to get rid of or pair up with somebody else. Sometimes you'll see hydrogen way up here, just to keep it separate, but still near its other friends and its property. Alkaline metals, at least the metallic ones, the actual solid ones, are really soft. You can cut them with a butter knife. They are incredibly reactive. Go find a YouTube video of somebody putting a little bit of, say, potassium in water, and you'll see flames spurting up. I mean, we're talking seriously reactive. The next group over is called the alkaline earth metals. These guys are a little bit less soft, a little bit less reactive, still pretty similar. Once you get here, 3 through 12, you're going to see some names you recognize, like gold or copper or zinc. Those are transition metals. They're nice and stable. They have different properties. And that's more of what you think of when you think of a metal. Once you start getting into groups 13 through 16, you're going to notice something different. This table, it starts to put nonmetals and metalloids in, say, the greens and blues. Once you get to boron, you're in a metalloid. It means it's kind of metally. It can have, any metalloids can be ductile or malleable, meaning you can hammer them into sheets, draw them into wire, or they can be brittle. They conduct electricity, but not as well as a metal. You start to get some metallic properties, some non-metallic properties. And if you notice, as you go over groups, you get more and more non-metal, and then less and less metal. And even these, in some charts, are designated as what people might call poor metals. They're not as great at being, say, hammered and drawn into wire and other stuff as some of the other metals. So once you have the non-metals, then you start getting into things that are possibly gases at room temperature, and usually they're indicated by a different color or a different color writing. When you get all the way to group 17, you have super incredibly reactive nonmetals, and these are called halogens. And halogens, like fluorine, chlorine, you don't usually see chlorine gas on its own because it's toxic and because it really wants to bond with other things. This group really likes to bond especially with group 1 to make salts. Once you have an alkali metal and you have a halogen, get them together, you have a salt. If you look at your regular table salt, it's sodium chloride, so it's going to be a sodium from group 1, chlorine from group 17. Then way over here are the noble gases. These guys, they don't really like to react with anybody. They have a full set of electrons, they're cool on their own, you're not going to see helium trying to bond up with anybody. They don't have anything that it needs because it just doesn't need anything. So you have helium, which is a nice stable gas. You have argon, which can be used in light bulbs to actually keep the filaments from burning out, and all sorts of other nifty stuff like this. There's a lot of information in the periodic table. This is just the very basics. The last thing I wanted to cover before I leave, way at the bottom of the periodic table are some elements where if they included them in the periodic table directly, they would actually be really, really wide. So this just kind of puts it to the bottom and make it fit on one page. This is the lanthanide series and the actinide series. And the lanthanides, very reactive, kind of soft. The actinides, cool thing about them, they are all radioactive. And you'll see some names you know down there, like, say, plutonium. All right, I hope this helped. Bye.